Okay, welcome back. In this video, we're going to look at the hybridization, how to determine the hybridization of atoms in some molecules. So the first question I have here is, what is the hybridization of carbon in carbon dioxide? What is the hybridization of carbon in carbon dioxide? So hybridization, like I mentioned before, depends on the electron density. It depends on the electron density. It depends on the electron density around the atom. So the hybridization of carbon in carbon dioxide depends on the regions of electron density of carbon in carbon dioxide. So here we're looking at the hybridization of carbon in what carbon dioxide, which is CO2. So this is an inorganic compound or an inorganic molecule. So what I would want to do is to draw the structural representation of carbon dioxide. Carbon has 6 electrons. It is the number 6 element in the periodic table, and so it has 6 electrons, right? Oxygen is the number 8 element and it has 8 electrons, right? So if I'm to draw out the configuration of carbon having 6 electrons, the first shell will take a maximum of 2 electrons. The second shell will take what? Maximum of 8, but there are remaining 4. So this is 1, 2, 3, 4. This is carbon, right? This is a carbon atom. Then oxygen has 8 electrons. So the first shell will take a maximum of 2 electrons. Then we have the next shell. So 1, 2, 3, 4, 5, 6, 7, 8, right? So this is oxygen. And then we have another oxygen because this is CO2, 2 atoms of oxygen. So the first shell will take a maximum of 2, and then the other shell. 1, 2, 3, 4, 5, 6. So this is what? This is oxygen atom having 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Right? So this is oxygen atom, this is carbon atom, this is oxygen atom. So we're looking for the hybridization of carbon in this compound CO2. So we are to look for the regions of electron density around this carbon. So this electron from this carbon will bind with this electron from the oxygen. This electron from this carbon will bind with the electron from this oxygen. This electron from this carbon will bind with electron from this oxygen. This electron from this carbon will bind with electron from this oxygen. So in this compound, we have 2 carbon to oxygen double bond. This is a double bond. This is another double bond. A double bond, a double bond. So we have 2 carbon to oxygen double bond, and this is equivalent or equal to 2 regions. 2 regions of what? Of electron density. So 2 regions of electron density is equal to what hybridization? It is equal to the sp hybridization, 1 s orbital and 1 p orbital. S plus p, that will give us what? 2. So that's the 2 regions of electron density. So the shape of this molecule will be what? Linear. And the bond angle will be what? 180 degrees. So it's a very straightforward thing and it's very simple. So let's look at the next example that we have here. What is the hybridization of oxygen in carbon dioxide? So here we looked at the hybridization of carbon in carbon dioxide. Here we are looking at the hybridization of oxygen in carbon dioxide. So we are looking for the hybridization of oxygen in what? Carbon dioxide, right? So this is oxygen having 8 electrons. This is carbon having 6 electrons, and this is oxygen having 8 electrons. We're looking for the hybridization of oxygen in carbon dioxide. So I can take any of the oxygen. So let me take this oxygen. In this oxygen, we have lone pairs of electrons. So this is a lone pair of electron. A lone pair of electron is a lone pair of what? Electron. A lone pair of electron is when we have two electrons that are not involved in bonding or that does not bind with other elements, right? So this is a lone pair of electron. We have a pair of electron that is alone. This is another lone pair of electron. It does not bind with what? Another atom. So this is another lone pair of what? Electron. So in this oxygen, we have two lone pairs of electron, and two lone pairs of electron, two lone pair of what? Electrons. And these two lone pair of electrons is equivalent to two regions of electron density. And then we have this double bond. This electron binding with this electron binding with this. So we have a double bond here. So there is one oxygen to carbon what? Double bond. And this is equivalent to what? One region, sorry, one oxygen to carbon double bond. This is the double bond here. We're looking at this oxygen. So that is equivalent to one region of electron density. So if we add this up, that will be a total of 3 regions of electron density. And 3 regions of electron density will be equivalent to what? Hybridization. It will be equivalent to what? The sp2 hybridization. 2 p orbitals and 1 s orbital, right? That will give you a maximum of 3, or that will give you a total of 3. So the shape of this molecule will be what? The shape of this molecule will be trigonal planar. The bond angle will be what? 120 degrees, because it is what? sp2 hybridized. So oxygen is sp2 hybridized in what? Carbon dioxide, and that will give rise to a trigonal planar shape, which the bond angle is what? 120 degrees. So let's look at the last example that we have here. What is the hybridization of oxygen in water? So we're looking for the hybridization of oxygen in what? Water, H2O, right? So oxygen has what? 8 electrons. Hydrogen has 1 electron. So if I'm to draw the structure of oxygen, this will be 1, 2, the innermost shell, and then 1, 2, 3, 4, 5, 6, right? Giving us a total of 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is oxygen what? Atom. And then this is hydrogen having just 1 electron. So this is hydrogen, and this is another hydrogen having just 1 electron, right? Remember, there are 2 hydrogen atoms in water, H2O. So in this compound, hydrogen would bind to oxygen. This hydrogen electron will bind to 1 oxygen electron. This hydrogen electron from another atom would bind with what? This oxygen electron. So, and we have lone pairs of electrons. So this is a lone pair of electron. This is another lone pair of what? Electron. So in this compound, we have 2 lone pairs. 2 lone pair of what? Electrons. We have 2 lone pair of electrons. and that is equal to what? 2 region. That is equivalent to 2 region of electron density. Then we have 2 oxygen to hydrogen what? Single bond. So this is a single bond, this is another single bond to another hydrogen. This is a single bond to one hydrogen, this is another single bond to another hydrogen. So we have 2 oxygen to hydrogen single bond, and that is equal to what? 2 region of what? Electron density. So if we add this up, that will result to a total of 4 regions. 4 regions of what? Of electron density. So if there are 4 regions, that will be equal to sp3 hybridization. And sp3 hybridization, the bond angle is what? 109.5 degrees. And that will give rise to what? A tetrahedral. Tetrahedral what? Shape. Right? So that is how to determine the hybridization of atoms in inorganic compounds, right? Or in inorganic molecules. So with this, we come to the end of this video. See you in our next video. Thank you very much for listening. God bless.